Let's look at solving problems with trigonometry. First, you need to review some vocabulary from geometry. The angle of depression is the angle that the eye moves from the horizontal to look at something below. So the angle of depression will always be measured from the horizon and then go down. The angle of elevation is the angle through which the eye moves up from the horizontal to look at something above. So if this is my horizon, then that is my angle of elevation. Now, the angle of elevation from the buoy to the top of the Ponce Inlet Lighthouse, 130 feet above the surface of the water, is 5 degrees. So this is a lighthouse. This is a buoy. Find the distance x from the base of the lighthouse to the buoy. Well, I have opposite and I have adjacent. So I know tangent of an angle is opposite over adjacent. So I know the tangent of 5 is 130 over x. Cross multiply, I get x is equal to 130 divided by tan of 5 degrees. Solving this, making sure my calculator is in degrees, I get 1,485.9 feet. So this is about 1,486 feet. Now, the Statue of Liberty stands on a 150-foot pedestal. So here is her pedestal. So this is a height of 150 feet. From a point of view, 280 feet from the base of the pedestal, the angle of elevation to the top of the Liberty's torch is 47 degrees. All right, so here we go. This is 47. This is 280 feet. We want the height of the statue. All right, so what equation do we have? I have, again, opposite and adjacent. So I know the tangent of 47 is, now the opposite side is h plus 150 divided by the adjacent, which is 280. So 280 times the tan of 47 is equal to h plus 150. So this is 300.263 approximately is h plus 150. So when I solve this for h, I get h is equal to 150.263 feet. This is a little more accurate than we need. Let's round it to the foot. H is 150 feet. Now, sometimes you need to make an indirect measurement. So the angle of elevation of the top of the TV antenna mounted on the Eiffel Tower is measured at an angle of 80 degrees, 1 minute. Okay. Now, whenever you're given an equation like this, you need to convert it to degrees. So when you do this, it becomes 80 plus 1 times 1 over 60 plus 12 divided by 3600. So we get 80.02 degrees. So this angle is 80.02 degrees. Now it's at a point 185 feet from the base of the tower. How tall is the tower? So this is my height. So I have opposite and I have adjacent. So I know the tangent of 80.02 degrees is equal to h divided by 185. So the height is 185 times the tangent of 80.02 degrees. Or it's approximately 1,051.33 feet. All right, now suppose we want to find the distance between 2 points. And I have a passenger who's in an airplane, and it is at an altitude of 9 kilometers. So that's how high the plane is here. This is going to be my Y measurement. And he sees 2 towns directly to the east of the plane. The angle of depression for the towns are 22 degrees and 46 degrees. So this one is 22 degrees and this one is 46 degrees. How far apart are the towns to the nearest kilometer? Well, if the distance from the airplane to the second town is x, and the distance from the plane to the first one, let's call that one y, then this distance right here is going to be x minus y. Now, let's come over here and translate these to 2 separate triangles. This triangle is 9y, and what is this angle right here? Well, if this is 46, all right, this angle right here is 90 minus 46, or 44. All right, so if I want to find y, I know tangent of 44 is equal to y over 9. So y is approximately 8.69 kilometers. Let me switch pen colors. The second triangle has a horizontal distance x, vertical distance 9, and this angle right here is 90 minus 22, which is 68. So we have the same situation. Tangent of 68 is going to be x over 9. So x, when I solve this, is approximately 22.28 kilometers. So the distance between the towns is x minus y, or 22.28 minus 8.69, or about 13.59 kilometers apart. Now, we can use trigonometry to do navigation. Suppose a U.S. Coast Guard patrol boat leaves port and averages 35 knots. This is a nautical miles per hour, and travels for 2 hours at a course of 34. So that's AB. So let's see how long AB is. All right, you remember distance is rate times time, and in this case, the rate is 35 knots. So the distance for AB is going to be 2 hours times 35 knots, or 70. All right. And then 3 hours on a course of 124 degrees. Okay, so that's going to be BC. So BC is 3 times 35, or 105. Now, we want to know the boat's bearing and distance from the port. Well, the next thing you need to do is kind of put these on your diagram. Now, if this angle right here is 56, all right, if this angle is 34, that makes this angle 56. And then when it turns here, what do we have? We have another right angle. Okay, so this is 34, and this is 56. All right, we know ABC is a right triangle, and 34 is an alternate interior angle. AC is the hypotenuse of ABC. So let's find the hypotenuse. Let's find AC. AC is the square root of 70 squared plus 105 squared, or 126.2 nautical miles. To find the bearing, for theta, it's going to be 34 plus theta, and this is going to be northeast, where this is theta, and this is 34. That's the bearing of 34 east. So the tangent of theta is 105 divided by 70. Solving this for the angle, theta is approximately 56.31. So the bearing is 34 plus 56.31, or 90.31 degrees northeast.